Okay, I want to do section 2.3, intersections and unions. Okay, so we're talking about sets. So intersection, we'll look at this definition and also draw a Venn diagram for it. Kind of like this where they say it's where two streets cross or where things overlap. So A intersect B, that's why I say that. And it's stuff that's in sets both A and B. So you're in A and you're in B. The Venn diagram, it would look like this. We have our two sets, A and B. The intersection is the overlap right there. Hey, there it is. So let's do an example. We've got our sets. Let's do A intersect B. This is the set of elements that's in A and B. So let's see, I see 4 in both, I see 5, and that's it. Now if I do A intersect C, looking for the elements that are in both, let me erase this. 3, 6, 9, none of those are in A, so this really is the empty set or the null set. There's nothing in the intersection. So that looked like this. They're disjoint, meaning there is no overlap. Okay, union, we're putting stuff together. It's the word or. So again, if I look at the Venn diagram, here's A, B. Well, we're going to take the stuff that's in A, which is this, or the stuff that's in B, which would be this. Basically, it gives us everything that's in the two sets. This is only in A, only in B, or both, right there. A to B or to both. And there it is. Just for the heck of it, the stuff that's out here, well, that's the stuff that's not in the union. That's the complement of it. All the stuff that's not in there. Okay, A union B. Well, I've got 1, 4, 5, 7. There's the stuff that's in A. Okay, I don't need to list 4 and 5 again, because I already got them. And then 2, 3, 6. A union C. I've got 1, 4, 5, 7. That's in A. None of these are in A, so I add all those again. I want to see if they show A union C. Nope. So this A union C, I want to draw a Venn diagram for that. You can see there's no intersection. So here's A, here's C. So I'm either in A or I'm in C or both, but there is no or both because there is no intersection. So, and intersection, because you're in both. Or is union, that gives you stuff that's in A, or B, or both. So it's everything. So I want to just look at these, maybe draw pictures for you. So I'll do this one first. We have 3 sets, and when we have 3 sets, we commonly do it this way. We'll have A, B, and C. So we have a lot of overlap. Nice thing about having colors is I can do this. I want B intersect C because that's in the parentheses. Let's see, B intersect C. This is the stuff that's in both B and C. Now I want to union A with that. Well, I take everything that's in A or everything that's in here, which is this. So if I continue shading, the purple is A union B intersect C. The thing that gets added is this little part of the intersection between B and C. Okay, next one. There's only 2 sets. When we do these, we always show an intersection, just in case there is. So here's J and K. So I want the intersection between J and the complement of K. So that's not in K. So I'm going to start there. I'm going to do it this way. Everything that's not in K, notice it's part of my universal. There's parts of J that are not in K. So it's just everything that has this red on it. Now, I want to intersect that with J. So everything that's in J, I'll make green. Notice it has this little part of K in there. But this is not in the complement, it's not shaded red. So if you look at just the double crosshatch, which maybe I can actually throw another color in here, blue, the stuff that's in the double crosshatch is just this. And that is J intersect the complement of K. You'll get a chance to play with a lot of these. Venn diagrams and equality of sets, I'm skipping those. You'll see those in another class if you take it. Now, involving 3 sets, I just did one of those, but here's what I don't do. They label, I don't know how many different regions are there, 7 different regions, 8. And then they do this. You can see I'm yawning because this is boring and there is no way that I'm going to expect you to know this, because we'll do problems in the next section where we'll be able to reason about them and fill in the numbers that go in those regions. So I'm not going to make you memorize this stuff. My gosh. So I will do some of this. I'm not going to do the regions. I'm going to do shading. A intersects C. Well, it's the stuff that's in A and in C. A union C. Oh, well, here's A or C or in both. So it's both those circles filled in. Now, this next one, maybe not as easy to do. Okay, A intersect B complement. I'm going to start with B complement. Everything that's not in B. All this stuff out here, it includes parts of C. Ooh, look, it's including part of A, but not the stuff that's shared with B. So there's the complement of B. Notice it's everything shaded blue except the circle B. Now, let's intersect that with A. Let's take everything that's in A and I'm looking for the stuff that's in both in the red and the blue. That's the double cross hatched. So if I did this with green, that's all double. Boom. Looks like a Pac-Man. So that's basically this section. We're almost there. See ya.